Hello, my guy. Yeah, okay. All right. So you've done limits, part of it.
Yeah, part of it.
Yeah. So now we want to revise some. Okay. So we're going to start with the basic limits. So we're going to start with some basic limits. So we are saying that given that A and C are real numbers, and N is a positive what? Is a positive integer. Then we have the following basic limits. The first one, we are saying that the limit of C as x is approaching A is equal to C. Then the second one says the limit of x as x is approaching A is equal to A. Then the third one, the limit of xn as x is approaching A is equal to A to the power n. These are the basic limits. And then we have given that the limit of f of x as x is approaching A is equal to L1, and the limit of g of x as x is approaching A equal to what? L2. We have the following limits. The first one, we are saying that the limit of C of f of x as x is approaching A is equal to C times the limit of f of x as x is approaching A. So what does this mean? What we mean is C is a constant, it's a real number. So what we are saying is if you are given a limit, to find the limit of a constant times a real number, what you do is you remove the real number and then find the limit of what? Of f of x. No, of f of x. And then you multiply it to the what? Yeah, to the constant. Then 2, the limit of f of x plus or minus g of x as x is approaching A is equal to the limit of f of x as x is approaching A plus or minus the limit of g of x as x is approaching what? A. So what we mean here is you are given maybe two functions that are either subtracting or adding. So what you do is first you find the limit of the first, you add or subtract the limit of the second. So the third one, we are saying the limit of f of x times g of x as x is approaching what? A. If you are given two functions that are multiplying, what you do is you are going to say the limit of f of x as x is approaching A times the limit of g of x as x is approaching what? A. Then for 4, the limit of f of x over g of x as x is approaching a. Hello? Right, I'll call you later. The limit of f of x. Alright. So now we are saying that the limit of f of x over g of x as x is approaching a is equal to the limit of f of x as x is approaching a over the limit of g of x as x is approaching what? A. Then this one is always true given the limit of g of x as x is approaching a not equal to 0, because we can't have a denominator 0, right? Then the limit of f of x as x is approaching a, this f of x is raised to the power n, is equal to the limit of f of x as x is approaching what? A, everything to the power n. We also have the limit of what? The limit of the nth root of what? F of x as x is approaching a equal to nth root of the limit of f of x as x is approaching what? A. So these are the rules, or let me just say properties of limits. So let's solve some questions. Oh, actually we've forgotten one, which is the limit of f of g of x as x is approaching what? A. This one will be equal to the limit of what? It will be f times the limit of g of x as x is approaching a. Here what I'm just saying is you find f of the limit of g of x. That's what I mean here. So now we are going to use, I'm going to show you some examples where we are going to use these things, the properties. So example 1. Example 1. We are saying find the limit of x squared plus let me say 3x plus 5 as x is approaching what? 3. Here we have this. So we've been told to find the limits. So we're going to use those properties. So the property 1, what does it say? It says that if you have a limit, if you've got functions that are either multiplying or subtracting, what we do is we expand, right? So we're going to expand. We're going to say the limit of x squared as x is approaching what? 3 plus the limit of 3x as x is approaching what? 3 plus the limit of 5 as x is approaching what? 3. Then here we say that if you got a function that is being raised to a power, what do? We say the limit of that function, everything raised to a power. We're going to use this rule here. So now this one will be the limit of which function? X. As x is approaching what? 3, everything to the power 2 plus, if we had the if we've got a constant times a function, what do? We remove a constant, then we say a limit of that function. Constant times the limit of that function. This is over here. If you got a constant and a function, we remove a limit, the constant, and then times the limit. So here you are going to remove the constant 3 times the limit of x as x is approaching what? 3. Plus, we said this one we're just going to leave it like this, in the meantime. 3, Then from there are those basic rules that we used. The limit of what x as x is approaching a is equal to a. So in this case, the limit of x as x is approaching 3, in our case, our a is 3. So meaning that it will be 3. So here we are going to have 3 to the power 2 plus 3.
So immediately you replace the x there, you remove the limit.
Yes, remove the limit. So and then we said that the limit same applies here. Even here to be what? 3. Plus, then we are saying that the limit of c, where c is any number, as x is approaching a is c. So the limit of a constant is always that constant. So here the limit of 5 as x is approaching 3 is what? 5. Therefore we're going to have 3 to the power 2 is what? 9 plus 9 plus 5. Then this one will give us what? This one is 18, 23. So this is the limit, right? Then we do another example. Let's do that example. Another example we are saying, find the limit of x squared plus x plus 5 as x is approaching what? Let's say not 3, let's say 2. X is approaching 2. So according to the rules, what's the first step? We distribute the limit. We are going to have the limit of x squared as x is approaching 2 plus the limit of x as x is approaching 2.
So the limit always moves with the x approach.
Yes. 5. Then from there, what are we going to do? We raise everything to the power 2. So we are going to say the limit of x as x is approaching 2 raised to the power 2 plus, there we are just going to leave it like that. The limit of x as x is approaching 2 plus even this one in the meantime we'll leave it like that. So now after this, what are we going to do? We are going to now evaluate the limits. What is the limit here? It will be 2. Remember the basic rules. It will be here 2 to the power 2 plus 2 plus 5. What is the value here? 4 plus what? 7, which is what? 11. So this is how we solve. If you are told to use the limit, the properties of the limits to do what? To find to evaluate limits. This is what we do. So now we are going to look at the methods for solving limits. Okay. Okay, we'll do it. All right. So now let's look at the methods for solving limits. Methods solving what? Limits. So the method that we use, we'll come to that. We'll look at those. So methods of solving limits. The first one, we've got the substitution method. Substitution method. The second one, we have the factorization factorization method. Then the third one, we have rationalization. Then the fourth one, we have limits at what? At infinity. So these are the things, some of the methods that we use when solving limits. But there are others. But for now, let's look at this. So now, let's look at this example. Limits at infinity. So now we've been told to find the limit of x squared plus x plus 5 as x is approaching what? 3. So we've been told to find the limit of this. So the first thing that we use, always you use what? First step, you use substitution method. So to do that, substitution means just get these 3 and plug in. So you're going to plug in, and then substitution method will always work for what? It will always work for what? For polynomials. Polynomials. It will always work for polynomials and some fractions. Not all of them, just some fractions. So now we've been told to do what? To evaluate that limit. So let's use substitution. Can substitution work here? Yeah. Yes, it can. So we say 3. The moment you start substituting, you don't write the limit. You stop writing the limit. Plus 3 plus what? 5. This one will give me what? 9 plus 8, which will be equal to what? 17. So this is the substitution method. Example 1. Example 2, we are saying, this one was 1, this one is 2. We are saying, find the limit of x to the power 4 plus 3x plus 10 as x is approaching what? 1. So here also, we can say substitution can work. We just go direct. We say 1 to the power 4 plus 3 times 1 plus 10. This one will be 1 plus 3 plus 10. This one is 14. Then remember I said that substitution method sometimes it will work for fractions. So we are going to look at this example for the fractions, which is 3. Find the limit of x squared plus x plus 2 over x plus 1 as this one x is approaching what? 1. So to find this, when you are given a fraction, to find out whether a limit will work, whether substitution method will work out or not, always substitute the denominator. If the denominator, yes, that is if you want to find out if it will work or not. If the denominator is equal to 0, then it can't work. We can't have a denominator 0. So if it's not equal to 0, positive or negative, then it will work. So in this case, it will be 2. So so we can just substitute, which is 1 squared plus 1 plus 2 over 1 plus 1, which is equal to, this one will give me 1 plus 1 plus 2 over 2. So we are going to have 4 over 2, which is equal to 2. What else are we going to do for? Okay, let's do for a negative. 4, we have the limit 8x cubed plus 1 over x minus 4 as x is approaching 1. So here what we are going to do is we substitute the denominator. The answer will be negative 3, so it can work. So we are going to substitute. You are going to have this plus 1 1 minus 4. So 1 to the power 3 is what? 1. 1 times 8. So we're going to have 8 plus 1 minus 3, which is 9. 9 minus, like that, which is equal to minus 3. So these are these examples were for now the substitution method. So now let me give you something interesting. We have a limit. We have the limit of x cubed minus 1 over x minus 1 as x is approaching what? 1. So now this method,
substitution.
we are evaluating. So now the thing is, if we substitute there in the denominator, what are we going to have?
0.
We are going to have 0. So meaning that substitution method have failed. We can't do substitution method here. So what we do is we try other ways. So the only thing that can work here, we go to the second second method, which is factorization. So this one is for the factorization method. So what we do here, this limit can also be written as what? We're trying to factorize this one. Can also be written as the limit of that x cubed minus 1 cubed as x is approaching what? 1. Like that. So now, how do we factorize 1, 3?
Wait, I didn't see where the cube came from.
This one? I've just put it there. Yeah, because 1 cubed is just the same as 1. I'm trying to factorize this because it's cubed. You know the difference of 2 squares, the difference of 2 cubed, or that thing. Now, for the difference for this one, there's this thingy which is a cubed minus b, the difference of 2 cubed. How do we find this? It is a minus b. Then we are going to have a squared plus ab plus b squared. So this is how we are going to factorize this. So in this case, our x cubed minus 1 cubed. This is the factorization of, how do we factorize difference? I mean, these are difference of 2 cubed. How can we factorize this? We factorize, I've just given you an expression that we can use to factorize this.
So that's how it's supposed to be factorized.
This is how it's supposed to be factorized. Now I'm factorizing now using this. Okay? So now this one will be equal to
X minus 1.
it will be equal to our a is what? X, minus our b is what? 1. Then our a is x, which is supposed to be squared, plus our a and b, we just multiply a times b, which is just x, plus what is our b? 1. 1 squared 1. Factorize up much. So what we are going to do is now we are going to say the limit of x minus 1 like that over x minus what? 1 as x is approaching 1. Now you can see that this and this, they are the same one. So what we are going to do is these guys will go. We are going to remain with the limit of x squared plus x plus 1 is equal to what? I mean, as x is approaching 1 is equal to what? So when you reach this point, after you factorize, again you employ substitution method. Can substitution work here now?
Yes.
Yes, it can work. So now we substitute. You're going to have 1 squared plus 1 plus 1, which is 1 plus 1 plus 1, which is just 3. This is our factorization method. Then another example, which is the limit as limit of x squared minus 4 over x minus 2 as x is approaching to 1. So this is a fraction. Like I said, substitution method can't work for all fractions. So when you substitute, you're going to have what? 0 there. So what we are going to do is we are going to factorize. So factorizing this, you can see that this is the difference of what? 2 squares. So this one will be the limit of what? X plus 2 x minus 2 over x minus 2 as x is approaching what? 2. Then these guys will go. They are the same one. So we're just going to remain with the limit x plus 2 as x is approaching what? 2. Now can we substitute here? So therefore our limit will be 2 plus 2, which is equal to what? 4. Now something else. The limit of x squared plus 3x over x as x is approaching 0. What are you going to do here? Can you substitute?
No, you can't.
Can you factorize?
You can factorize.
What are you going to factorize?
Factor out the x.
When you factorize the x, when we do this, it will be x plus 3 over x. So it will be the limit of x and x plus 3 over x as x is approaching 0. This and this, they are the same. They will go. We'll remain with the limit as x is approaching what? 0. Can we substitute? Yes, so it will be 0 plus 3 equal to what? 3. We have something interesting there. Okay, yeah. So let's do this other example, which is we have the limit of x squared plus x minus 6 over x plus 3 as x is approaching negative 3. So in this case, can you substitute? We can't.
Okay.
So we need to factorize the denominator, the numerator. So let's use the try and error method. We're going to get our 6. So then we are going to say we look for the factors of 6. We got 1 and 6. 1 times 6 is 6. 2 times 3 is what? 6. These are the only factors. So among these factors, you choose the ones such that when you subtract them, they would give you the coefficient of x. So you see that again, when I subtract 3 minus this, they'll give me 1, the coefficient of this. So meaning that I'm going to have x there and x there, the bigger one there, the smaller one there. The sign of the middle term will be there. The sign for me to get a positive, I must have a negative there. So therefore, the factorization of this is this. Therefore, I'm going to have the limit of x plus 3, x minus 2, x plus 3 as x is approaching minus 3. This and this will go. I'm going to remain with the limit of x minus 2 as x is approaching negative 3. Then from there, just substitute. Minus 3 minus 2. What is the answer? Minus 5, right? All right. So another example, we have the limit of x plus 1 minus 1.
This part has been left out. How? We just have to solve for this.
No, I'm coming. This part, you factorize this part. When you factor, this is a quadratic equation. When I factorize it, would give me this. When I factorize this one, the factorization of this one will give you that. That's what I've used here. So now we have this example here. We have the root of x plus 1 minus 1 over xi. So now we need to work to find the limit of this as x is approaching what? 0. So find this limit. So can you do substitution there?
No.
Try to factorize. Can we factorize? We can't factorize. So these are the cases of you can factorize. I mean, you can substitute, factorize. Some things you can do that. So what you are going to do, you are going to go to the third step that you can try when evaluating limits. So this is the what? Rationalization. So what do we mean when you're told to rationalize? To rationalize, we are told to multiply by the conjugate. That's the rationalizing part. So in this case, the rationalization of this one, we are going to multiply by the conjugate. So to multiply by the conjugate, we are going to say x plus 1. What is the conjugate of this?
Plus 1.
It will be plus there. I'm not changing the sign of this. This thing is 1. So I'm just changing.
We're just using that.
Over the root of x
In that
plus
case,
1 plus
we're
1.
using the conjugate of it of the denominator.
So if, so the thing is, if you are told to rationalize, you need to identify which part has got a radical symbol. So if the numerator has got a radical symbol, then you are rationalizing the numerator. If the denominator has got a radical symbol, you are rationalizing the denominator. And if you're rationalizing the denominator, do not tamper with the numerator. If you're rationalizing the numerator, don't tamper with the denominator. So in this case, which part are we rationalizing? The numerator. So we're not supposed to do anything with the denominator. So we're going to have the limit of we multiply this times that. This times this.
Root of x plus 1 brackets that.
The root of So this example, for example, you have the root of, maybe let me say the root of 15 times let me say the root of 4. The root of 4 times the root of 5. What is the root of 4? It's 2 times the root of 4, 2, which is what? 4. So if you are given such things, just get one of these. So in this case, I'll just get x plus 1. This time this x plus 1. This times this, it will be plus 1 x plus 1. This time this, it will be minus 1 x plus 1. This times this, it will be minus what? 1. Always remember that you don't do anything to the part where you're not the part that you're not rationalizing. So it will be x. This one will be just gotten like that, plus 1. As x is approaching what? 0. So now this part is positive, this part is negative. So these guys will do what? Will cancel. We're going to remain with x plus 1 minus 1 over x, the root of x plus 1 plus 1. The limit as x is approaching what? 0. So this is positive, this is negative. So even these guys will go. So we're going to remain with x. X, the root.
Which guys will go?
Plus 1 minus 1. The limit as x is approaching what? 0. Now you can check. I can't still more here. I can't factorize. I can substitute. So I'm going to do this and this. They are the same. So they'll cancel. If you cancel this one, you're going to remain with 1 there. So if you cancel this one, you're going to have a 1 there. So we're going to remain with 1 over the root of x plus 1. Like this. So now from here, can I substitute? Yes, I can. If I put 0 there, I'm going to have the root of 1. So meaning that I'm going to have 1 over the root of 1 plus 1, which is 1 over, what is the root of 1? It is 1. Plus 1, 2. So this is my answer. Okay.
Got this first.
Yes.
How about if
Actually, but none. But the camera, yeah, come.
Oh, I know it's fine to continue. Alright, let me do this. So we said that we find the limit of what? X minus 1 over the root of what? X minus 1 as x is approaching what? 1. So if we substitute there, we're going to get 0 over 0. So the only thing that we can do is rationalizing. So we need to identify which part are we supposed to rationalize? The denominator. So we multiply by the conjugate of the denominator, which is x plus 1. Even there, plus 1. So now what we do is, if we are rationalizing the denominator, the numerator, we don't do anything to it. So we just get it the way it is. It will be the limit of x minus 1 times x plus 1 over here, this time this, it will give me x. This times this, it will give me plus root of x. This and this, it will give me minus the root of x. This and this will give me what? Minus 1. As x is approaching what? 1. Then we're going to have the limit of what? X minus 1. That over, this is positive and that's negative. So these guys what? Will go. We're going to remain with x minus 1 as x is approaching what? 1. Then from there we can see that this and this, they're just the same way. So they will go. We'll remain with the limit of x plus 1 as x is approaching 1. So from here, can we substitute in this case? Yes, so we're going to say the root of 1 plus 1. 1 plus 1, which is what? 2. So this is how we do it. Alright. Do you have, how many papers did I write for this one?